Welcome back everyone. Now here I come back with the mass spring system. So mass spring system ላይ መርሳት ከሌለብን አንደኛው ነገር ቢኖር sometimes oscillate የሚያደርገው ማሳችን maybe attached to a fixed well, and that case that fixed well is attached to the mass by some springs. So yes, springoቹ constant K1 and K2, so the combination ናቸው might be in series or in parallel. So in that case we need to find the effective spring constant first. So the effective spring constant for series connection and also for parallel connection. So as you see here, the effective spring constant for this case, in this case the first will be in parallel connection and the second you see in series connection. So actually we don't need any further proof, so proof azika anadergam. So what I'm going to do is simply showing you the effective spring constant for parallel and series connection. Of course, for parallel connection, the effective spring constant would be the sum of the spring constant. So as it does any capacitor connection, K1 plus K2 ይሆናል ማለት ነው። So in series connection, the effective spring constant, K effective, would be K1 times K2 divided by K1 plus K2. Here actually we are considering two spring system, and for more general, for multiple spring constants, the effective spring constant would be the sum of individual spring constants. If we simply attach a mass by multiple springs, let's say n number of spring, so the effective spring constant would be the sum of all spring constants. So this would be a general formula. So for parallel, for series connection, this would be of course the inverse of the sum of the inverse of a spring constant. So 1 over K effective would be the sum of 1 over Ki, where I runs from 1 up to for n number of connection. So here we have a general expression. So no matter how much any number of springs, so it's easy to find the effective constant using this formula. So in fact previously ካየነው expression specific case ወስደን related የሆኑ ኳንቲቲዎችን ሶልቭ ማድረግ እንችላለን, such as angular frequency ሊሆን ይችላል, period frequencies እና ሌሎችንም ኳንቲቲዎች. So ከዚህ ለምሳሌ ካየነው problem, let's say here we have example. Let's consider a spring constant of K, two springs having a spring constant of K connected to a mass of M, and here, so the question is, what is the angular frequency of the system? So that being said, here object action as perturbed by some random force, it will make a harmonic motion. So that harmonic motion will have a certain angular frequency then. So the angular frequency is simply would be the omega of the angular frequency would be square root of k, or a spring constant, effective spring constant, divided by the mass of the block. So if that's the case, here the effective spring constant, since for its parallel connection, would be the sum of spring constants. So k plus k. So we would get 2k. So the angular frequency would be square root of 2k divided by m. በተመሳሳይ ኬዝ ለሲሪየስ ኮኔክሽን አይተን ኮምፓሪዥን መፍጠር እንችላለን ፋይናሊ ማለት ነው። So the same case for series connection, here let's consider springoቹ በሲሪየስ ኮኔክሽን ከማስ ኤም ጋር ነው የተገናኙት እንበል። ስፕሪንግ ኮንስታንታቸው k ነው። So that case would be the same question is also asked for series connection. So we need to find the angular frequency of springs connected in series to a mass m. That case the angular frequency of course will be square root of the effective spring constant divided by the mass. Since the effective spring constant in series connection, we have found that the 1 over effective spring constant would be 1 over k plus 1 over k. So k effective would be, of course, with simple mathematical manipulation, we would get k squared divided by 2k. So k effective would be k squared k divided by 2. So here the effective spring constant would be half of the spring constant of the one spring. So the angular frequency finally would be square root of k over 2m. So እዚህ ጋር ምን እንመለከታለን? When the springs are connected to a block in series in parallel, angular frequency would be different thing. የምታዩት የአንጉላር ፍሪኩዌንሲያቸው የተለያየ ነው። So let's say this is angular frequency of in a parallel connection. This is angular frequency in a series connection. So by comparing both spring constants, let's make some comparison. So let's divide the angular frequency of the parallel divided by the angular frequency of the series. So the angular frequency of the parallel is simply square root of 2k divided by m divided by square root of k divided by 2m. So as you see here, you would get the result gives you 2. Here we can cancel k by k here, we can cancel the mass, and of course this thing gives you 2. So this tells you, therefore, angular frequency of in parallel connection is equals to twice of angular frequency of series connection. So many ይነግረናል ከዚህ result, when springs are connected in parallel, they yield or they produce a higher angular frequency than a series connection. So this would be some revision on a spring mass spring system. So you need to be able to solve effective spring constant and then related quantities such as angular frequency, and you might go on like frequency, period, and other quantities. So this would be enough for this video. So I'll see you on another problem. See you next time.